Welcome everybody to our actually third Berkshire Watershed Institute presentation of this winter. For those of you that are maybe joining us for your first Roaring Fork Conservancy program, I really want to welcome you and thank you for joining us. If you get a moment, I know that some people have been using Zoom a lot, but for some people, this is a new platform for you. If you toggle your mouse at the bottom of your screen, you should see a little box that says chat. If you wouldn't mind letting us know how you heard about tonight, that would really help. If you could just let us know if it was Facebook or email or the newspaper, it helps us know what are the best way for us to disseminate public relations for upcoming programs. So if you could just write me a little note there, that would be so great. I think you know that Roaring Fork Conservancy is the watershed organization for the Roaring Fork Valley. We're actually in our 24th year right now, and our mission is to inspire people to explore, value, and protect the Roaring Fork watershed. And we reach about 6,000 people every year through our education programs, both for school programs, and for families, for adults. For many of you, including us, having virtual presentations is a relatively new endeavor from this year, or from this past year. So thank you for joining us. We know we'd rather see each other in person and have this presentation in person, but appreciate your time here this evening. So what is the purpose of tonight and the Berkshire Watershed Institute? Berkshire Watershed Institute was set up by us about a year and a half ago, but it's been almost a 20-year-old idea. And the premise of it is we want to invite water leaders from around the state, around the country, to talk about current water issues and water events, and relate it back to the work that we're doing here in the Roaring Fork Valley. So we're really excited to have Kendall here tonight. We have had a long-standing relationship with Kendall, probably ever since you came to Colorado Parks and Wildlife. So we're so excited to have you here. Kendall has almost every year, either hosted by us or other organizations in the Valley, given a presentation on fish stocking programs. So an update on like what how the fisheries are doing in our area. But tonight's presentation is going to be a little bit different, as you know from the science. We really wanted to invite Kendall here to talk about how fish react to water, which is really a result of lower flows and higher air temperatures. And as you're aware, we had that situation here last summer. We're hoping to get some more snow here in the next few months so that we don't have a similar situation here this summer. But in the meantime, we know that all of us as anglers are part of the solution. So thanks for being here tonight. We would be going to have some questions tonight, and so this is an informal evening. Again, the idea is that you all have access to a water leader, which tonight is Kendall, to be able to ask these questions. So if you have a question, please feel free in the chat box to just be like, hey, I have a question, and then I'll go ahead and interrupt Kendall. She doesn't mind questions per slide, or we could wait till the very end. That's fine as well. So without further ado, let me introduce you all to Kendall. Kendall is the state's aquatic biologist for the Roaring Fork, Eagle, and Middle Colorado watersheds. She has been based out of the Colorado Parks and Wildlife Glenwood Springs Service Center since 2007. Kendall is a third-generation Colorado native that grew up in Golden. She ventured out of state for college for her earning an undergraduate degree with majors in biology and education from Cornell College, where she studied raptor migration patterns and spent 3 summers at a field research station in the Boundary Waters. She went on to pursue a master's degree in fishery and wildlife biology at Colorado State University, studying the physiological effects of temperature on adult spring run Chinook salmon in the Trinity River in Northern California. Kendall has 2 wonderful kids that spend much of their time tramping around with her through the deserts and mountains, enjoying our amazing natural resources, and assisting as probably some of the youngest interns with fisheries projects on the Western Slope. So thanks so much for being here, Kendall, and the mic is yours.
All right, thank you. So tonight I'm going to talk to you guys about the hot times that our Coldwater sportfish have been experiencing and what that what that looks like for them, how it affects them. So I'll talk to you about what fish are, which is probably a word you've never heard. Why hot flashes are stressful. I'll introduce you to our Coldwater Locals. Talk about their thermal thresholds. I'll discuss also how heat and oxygen can interact, as well as what influencers there are for river temperatures, how to address fish stress, and some of the local impacts that we've been addressing. And then if you've got any more questions, you can ask them at the end, but feel free to ask me questions along the way. Christina will interrupt me and either let me know your question or have you voice it. So fish are what? Well, fish are poikilotherms. I bet you've never heard that. You've probably heard endotherms and ectotherms, but they're poikilotherms, which means that they've got variable body temperatures. So a homeotherm, which is what we are, have a pretty constant body temperature throughout the day. And fish, their body temperatures change with the environmental temperature, but they're not just ectotherms, which means a body that is influenced by the external environmental temperature. They actually have body temperatures that can be a little bit different. So how do they do that? Well, they can manage their body temperatures through behavioral thermoregulation, which means they can choose specific habitat types. So for instance, in our low water, hot summers, they often will be found in deeper, colder waters near the bottom of rivers or bottoms of pools. They might move from the outside of a river along the edge to the interior where the water is deeper and cooler. They also move. Fish, trout in particular in our area, can move tens of miles to avoid hot temperatures and lower elevations and move farther upstream. So hot flashes are stressful. These hot flashes that we're getting in the summers in particular, and what happens with fish is it increases their metabolism. So metabolism is basically uses the amount of energy that we have in our body to do the tasks that we need to do. It's a little bit like a gas tank. So you can fill up your energy tank with food, but you use that gas when you move, when you grow, when fish spawn, when we reproduce, those kind of things. And the other thing that affects them is temperature. Since they are influenced by their environment, their metabolism, their energy use actually increases. So in our environments, there will be, in fish environments, there will be acute and chronic stressors. So acute stressors are those very short-term stressors that can cause a lot of impact versus a chronic stressor that might be felt over time. With acute stressors, you would probably, a fish would get sick pretty fast, they could die, they could lose their equilibrium, which means they can't stay upright. And that would be something that would be lost pretty quickly once they're exposed to a high temperature. A chronic stressor, like a chronic temperature stressor, would be some environmental temperature that's higher than their optimum that would cause impacts to their energy use over time that could affect that energy and how it's being allocated to other functions in their body, like how they grow or how they develop eggs or milk and reproduce. It can impact egg quality. It can change behaviors. They might become more lethargic and not able to eat as much because they can't move because they don't have that energy to move and eat. So there are a lot of things that happen when there's chronic stressors. So what does a stressed fish look like? One, they might respire at a faster rate. So you'll see their gills flaring out and moving faster. So it's kind of like us when we go into a state of stress, and stress can be good or bad, we'll start to breathe faster. Same with fish. they'll have lower growth because they're spending more time taking in oxygen or just sitting in their environment. It takes them more energy with higher stress. And in particular, tonight we're talking about temperature. So they'll have less energy in their bodies to spend growing. That can also be related to if they're so stressed they're not moving very much. They might not be hunting for their food, for their prey items. It can reduce their ability to fight off disease. It can lower their immunity responses. So there's a higher incidence of disease, as well as diseases or, viruses and fungus and things like that in their environment that may not be something that would impact them, except for the fact that when their immune system is impaired due to a stress, they may not be able to fight it off, and that can cause a disease that you might not otherwise see. For example, saprolegnia is a kind of fungus that you'll see on fish that's white, and oftentimes you'll see it on old fish. At the end of their lives, you'll see this white fungus grow on them as they're dying because their bodies are shutting down. But if there's a stressor out there that's impacting maybe a not so old fish, what would otherwise be a healthy fish, they too will suffer from these kind of impairments. I mentioned before, it can inhibit reproduction. It can decrease egg quality or milk quality. So even if they are able to reproduce, they do find the conditions that they want to reproduce in, they may have lower egg quality and lower survivability of their young. And then it can decrease movement. I've talked about that a little bit too. Any kind of stressor, but in this case, temperature can reduce movements as well. They can move to a void if they know where to go, or they can find somewhere to go, but eventually they will stop moving. For instance, in the Crystal River just this summer, we had very, very low flows there, and temperature wasn't as big of an issue as it was in the lower Roaring Fork in the Colorado at times, because there's some fairly cold water inputs there. There were a lot of fish that couldn't move very far, or if they could, they were laying on the bottoms of the pools, just not moving because they just couldn't get anywhere. And temperatures were warm enough that would cause them to do that. So let me introduce you to your Coldwater locals. We've got the rainbow trout, the well-known rainbow trout from Colorado, or in Colorado. However, they are not from Colorado. They're actually from the western coast of the United States. If you didn't know, a rainbow trout that goes to the ocean is called a steelhead, and I'm sure you've heard of steelheads too. Well, they're just rainbow trout. They were originally brought into Colorado in the late 1800s. They were moved out of Northern California, many of the stocks, but they've been transported all over the world and introduced everywhere. Rainbow trout are a part of the Oncorhynchus genus, which also is the genus that contains the Pacific salmon as well as our cutthroat trout. And so these fish are spring spawners, just like our cutthroat trout. And we also have brown trout. Brown trout are from Europe. We brought them over in the early 1900s. They are a different genus than rainbow trout. So one big deal about that is that when you're at different genuses, you usually can't hybridize. So with rainbow trout, one of our concerns with that introduced fish is that they can hybridize with our native fish, but a brown trout cannot. They are a fall spawning fish. And then the last one that is one of our introduced fish are brook trout, the Salvelinus genus. They are a char, so a little bit more closely related to a brown trout, but of a different genus. Those two can hybridize, but their hybrids are sterile. And brook trout come from the eastern United States originally, and they were a very, very popular fish to produce especially in the Upper Roaring Fork in the late 1800s and early 1900s, and they were just put all over. Where you can find these fish, brown trout and rainbow trout, are in our lower elevation, kind of bigger waters, whereas brook trout are up in our higher elevation, kind of smaller water streams. And brook trout too are a spring spawning fish, or I'm sorry, a fall spawning fish like brown trout. And the next group of fish I'm going to tell you, they are our Coldwater locals, but they're also our Colorado natives. Mountain whitefish are a native to the state of Colorado. However, they are not native to the Roaring Fork and Colorado rivers. They are native to the White River and the Yampa River, and most of their native distribution is north, in the northern part of Colorado, and then up north through Wyoming and Montana and Idaho. Mountain whitefish are a trout cousin. They're in the salmonid family. And they are a big silverfish. People often catch them around here and then call me and ask me what the heck they caught, because they've got a weird mouth that doesn't look like a trout. They've got big scales that kind of looks like maybe a carp, but you'll notice they also have a very big adipose fin, which is indicative of this the salmonid family. You know, trout also have an adipose fin behind their top dorsal fin that is quite a bit smaller, but the mountain whitefish has a notable one. And of course, we have our native cutthroat trout. The greenback cutthroat trout is the state fish. That is the cutthroat lineage that is indigenous to the eastern side of Colorado. We have a recently acknowledged lineage of cutthroat trout that we did not have identified, that is only native to the upper Colorado River in Colorado. And at this point, we call it the green lineage. It's not a very sexy name, but it is one of the most beautiful trout, and we only have a few of them left. So one of my jobs is to expand and protect the populations out there. And then this little guy, he's not a sportfish, which is what I'm primarily focusing on, but this is a sculpin, and they are a native fish, and they are a cold water fish, and they are an important prey item for trout. So if you want a really big trout, like the one you saw in my first picture, usually they have to be fish-eating fish. So the sculpin make for big trout. So let's get back to temperature, and I'm going to talk to you about thermal thresholds. So thermal thresholds are kind of those levels at which trout are existing in their most optimal conditions. Here in blue, and you'll see on the left side is temperature. You'll see red here, that is a stressful temperature interval there, and then yellow is kind of where they die. That's the critical thermal limit there that can cause high mortality and disease and death in the fishes, the cold water fishes that we're talking about tonight. So I'm going to give you three groups of fish here, and you can see I've already given you a hint that they are trout or salmonids that we're going to be talking about. But we've got a group that's got a little bit higher tolerance range. We've got a group that's got a lower tolerance range, and then we've got kind of the in-between. So I know you guys aren't in front of me right now, and I can't hear you all, but just think in your mind, where do you think our fish that I just described fall? We've got brown trout and rainbow trout that tend to be low elevation. We've got brook trout and cutthroat trout, which I didn't specify, but those are the high elevation trout. And then we have whitefish that tend to be also in the waters where we find like bigger streams where we find brown trout and rainbow trout. And I'm also gonna give you a hint that think about temperatures as you go up in elevation, what they do. They tend to get colder. So if I were a guessing person, although I know better, I would say this looks like our cutthroat brook trout, right? They're probably lower tolerance, the coldest of the cold fish, right? Well, that's not them. Cutthroat and brook trout have an intermediate tolerance for temperatures. So they like the cold, 50-degree temperatures and lower, but really their optimal range is about 50 degrees to just over 60 degrees is where they find their best growth. They've got just everything's going right in their environment if temperatures are in that 50 to 60 degree range. And then once you get about 63, 62, 63 degrees, they start to get stressed. And that's where you start to see impacts to growth. If you're doing physiological studies, you're going to be able to measure those stress hormones, just like we have, cortisol, those kind of things. And then once you get to almost, just around 70, just below 75, that's when you start to see pretty high death in those fish if they're just exposed for an acute amount of time, a short amount of time. Our most sensitive fish is actually the whitefish. Mountain whitefish, they have a lower thermal optimum. They actually do best at the lower, colder temperatures. And they start to stress actually about in the mid 60s. And then you start to see pretty high mortality once it gets to be the mid 70s. And maybe not surprising to many of us, brown trout and rainbow trout are our most tolerant of our cold water fishes. They have the highest range of optimal temperatures between 50 and about 68 degrees is their thermal optimum. They start to stress after 68. You start to see impacts to growth, some inhibition in reproduction, and then you start to see pretty high mortality once you get to the high 70s. And that's if they're exposed to those temperatures and can't leave. I don't know why those fish want to keep disappearing. One fish I did not put on here because we're focusing on sportfish is the sculpin. And sculpin have a tolerance around that of kind of in the middle, kind of where cutthroat are, but where we find them is in our bigger rivers and where we find rainbow trout and brown trout, although we do see them in some higher elevation streams. So the other element that's really impacted by temperature and as of major importance to fish is dissolved oxygen. And we measure that in parts per million, which is the same as milligrams per liter. And what we find here in this table, you can just generally see red is lethal, yellow here is stressful, and green is optimal. And you can see there's a little bit of difference, and this I didn't point out earlier, but in thermal tolerances, juveniles tend to be more tolerant than adults. And we also see this kind of bear out in oxygen too. They can be a little bit more tolerant of lower dissolved oxygen levels than adult fish, where their stress is felt at a higher dissolved oxygen limit. And then their optimal conditions are quite a bit bigger. So juveniles tend to be quite a bit more adaptable. An interesting thing here in this graph, you can see trout eggs tend to need more oxygen than adults, which is kind of strange. If you know anything about how trout reproduce, they dig these holes we call redds with their tails in rivers, and then they drop their eggs. And typically you would think maybe oxygen would be limited in between rocks and stuff. You get higher oxygen where the water is kind of mixing around. But they actually pick gravels that have an upwelling of water through them. And those gravels tend to be at the tail out of a pool where the water is coming up and is actually highly oxygenated. So it creates a highly oxygenated environment for those eggs, and they need that oxygen, and they've shown that in research. And how is dissolved oxygen controlled? I took some of these figures just off the internet. I thought this was a cute one, but this makes the points that I wanted to make to you tonight about dissolved oxygen. It's controlled by 3 factors. There's the physical factors. Is there a lot of turbulence? Is it, a high gradient stream with a lot of turbulence? You're going to see more oxygen. If it's a stagnant area in a lake, or this is kind of the ocean or an estuary, you might see lower oxygen because there's just not that mixing from turbulence just moving down the stream. Salinity, the amount of salts in water, is going to impact the amount of dissolved oxygen. You're going to have lower amounts of oxygen down here versus in salt water versus upstream where there's fresh water. Fresh water has high amounts of dissolved oxygen. And then biological effects. If you are in a bowl that's not mixing, like a pond or an aquarium or somewhere like that, then it depends on how many critters are in there using up oxygen too. So sometimes we see low oxygen in some of our rivers and streams when there's very low water and they get trapped in pools that are isolated. You won't have a lot of mixing and you'll have a lot of fish stuck in a pool, and that can lower the oxygen. But and then also as temperatures increase, with higher temperatures, you have less dissolved oxygen. And then one other biological control you've got is this is algae and other kind of vegetative growth. It's interesting, during the day while they're photosynthesizing, they're going to put more oxygen in the water, which can be good. But at night, as it dies back or it stops photosynthesizing, that there's actually more oxygen that is used up, and that'll actually lower dissolved oxygen content. So oxygen is very closely tied with temperature because of the amount that is in water at certain temperatures, but there's also other factors that can impact oxygen. So moving back to temperature, I want to talk about how our cold water fishes are distributed in Colorado. And let's talk about the 800-pound gorilla in the room, climate change. You know, climate's changing. We are heating up on this planet, and we in this area live kind of on the threshold of cold water and warm water, particularly if you're down around Glenwood Springs. We really start to, in the Colorado River, transition from a cold water river to a warmer water river around Rifle. And we see that in the fish assemblages. You'll see a wider variety of fishes downstream around that area that are native as well as non-native. So the distribution of cold water fishes is influenced by temperature, and as climate changes, we're going to start to see those distributions changed of our cold water fish. And this is going to happen directly by the fish. They're going to move out of habitat that is not desirable, right? They're going to move upstream in the summertime. We might see high mortality during high temperature, low water periods. And that's going to it could likely become more frequent. Indirectly, we're going to see impacts to populations. We're going to see them kind of change because as their metabolisms increase with temperature, they're just not going to grow as well, and they're not going to reproduce as successfully. So if temperatures kind of changing gradually, we're going to probably see some of these populations just kind of die back little by little. Distributions of populations will also shift. Like I said, they're going to move. They're going to shift either directly or indirectly. They're going to move north, because as you go north in latitude, you're going to start getting into cooler temperatures and cooler waters. But in Colorado, our cold water fishes also have an advantage because they can move higher in elevation. So they, for the most part, can move upstream. One fish in particular that is the most disadvantaged that I see are the mountain whitefish. As you saw back on the thermal thresholds, they are way less tolerant of high temperatures. And the other thing that we find, and it's not entirely clear why, Mountain whitefish, while they do prefer colder temperatures, they do not exist in our high elevation streams. So there's something about habitat that that there's not optimal conditions there outside of temperature. So unfortunately, they have that lower temperature tolerance, but they also have the desire to be in larger waters that are kind of lower gradient waters. And so they're gonna have a hard time in places. And I guess, like I just said, they're less tolerant than brown trout or rainbow trout. And also that makes them more susceptible to invasions when warm water predators come in. And one example of this is the Yampa River. So mountain whitefish are native to the Yampa River. We introduced them into the Colorado, or actually into the Roaring Fork River in the early 1940s. And they have moved downstream into the Colorado River, headed upstream in the Colorado River from the Roaring Fork. And then potentially we've also had some come through the diversions from the Yampa River to the Colorado River. So it's likely we also had this unintended invasion occur through those structures. But either way, they've moved up the Colorado River, and my counterpart and I upstream have been documenting their invasion above Gore Canyon. It used to be, when I first started in 2007, that whitefish were not above Gore Canyon, and now we're starting to document not only individuals up there, but reproduction up there. But in the Yampa River, as temperatures are warming up, we have non-native fish that have gotten into that river, both smallmouth bass and pike. And while they don't do well in many years, in warm, low water years, they do very well. And they are right at the edge of where mountain whitefish reproduction occurs. And so hand in hand with the invasion of those fish, we've seen the decline of our endangered fishes, as well as there's a documented decline of mountain whitefish in the Yampa River that may also be feeling some impacts by the invasion of those warmer water predators.
Kendall, do you mind if I interrupt you real quick?
Yeah, please.
Tony has a question for you. He said,
okay,
that brown trout can take more heat than other species. Is that true?
They have a little bit higher, like maybe a degree higher temperature tolerance for higher temperatures than rainbow trout on average. They certainly have higher temperature tolerances than some of our cutthroat trout species. We see that there's actually quite a bit of high temperature tolerance in cutthroat trout, depending on where the population is. If they're in the southern part of the range, they're kind of acclimated to higher temperatures. So they also have a little bit higher temperature tolerance, but not as much as brown trout. But they still kind of have that upper limit up in the higher 70s, where you really start to see major stress impacts on reproduction, growth, and mortality.
Great. Is that good, Tony? Do you have any more? Are you good?
No, I'm good. Thank you.
Okay, thanks, Tony.
All right. So what influences river temperature? Well, if we have more water, right, that's going to make river temperatures less susceptible to hot summer days or even really cold winter days as well. And how do we get more flows? Well, you know, some of the influencers are just Mother Nature. What's the snowpack going to be? I suppose there are potentially efforts out there to seed clouds and get more snow for recreation, but also for water. I don't know that we've seen ever any significant increases to snowpack that we really realize lots more water in our rivers, but that is one way to influence temperature, is to increase the snowpack. Another way that we can influence temperature in our rivers is to release water. we can release water from our reservoirs, and we do through a variety of different programs for fishes and for water users. But we have used water out of Rudai Reservoir to cool, to help cool the river downstream, both the Frying Pan and the Roaring Fork. We've also used reservoir operations on the Colorado River to help decrease temperatures in the summers. Groundwater is another significant contributor to cold water in the summers. We see trout, especially one place that we see them is around the Crystal Hatchery. We've got a lot of upwelling of groundwater into some of our pools in the river, and you'll actually see trout lay on those cold water inputs, which is kind of interesting because a lot of groundwater inputs tend to be very low in oxygen, so they will trade off the loss of oxygen for the decrease in temperature on their bodies. So an important way to help protect groundwater is not pumping out that groundwater, not using that groundwater, and also to protect things that contribute to groundwater like agriculture and irrigation. Another way to influence temperature is to improve habitat. Pools, deeper areas in our rivers and streams can provide cool places for fish to find refuge during hot times. Also during cold times, they don't freeze all the way down. We also find that healthy riparian cover can help shade rivers and cool rivers. So it's very important to protect those areas. We see fish during hot periods. They're not only jumping from pool to pool, they're using those cooler waters that are shaded in streams and rivers too. I did my graduate research, if you heard in my introduction, was looking at the effects of temperature on adult Chinook salmon. And so I did a lot of research on just the physiology and behavioral regulation of temperature by fishes. And there was one study that found that there are salmon out there that can change their body temperatures by up to almost 3 degrees Celsius, which is, approximately 6 degrees Fahrenheit, just by changing their positions in a river during a hot period. They're able to be that much cooler than the environment just by chasing these cool areas in the river. And then it's really important to keep our rivers connected. As we talked about, they move to the cooler waters, and if our rivers aren't connected, if fish can't get upstream, they're going to have a hard time finding cooler conditions, and then also invading into habitats that are and moving into habitats that are more desirable as these temperature increases become more of a norm. So how do we address stress in fish? We talked about how we address river temperature, and I talked a little bit about how we do that. Oh, one thing I wanted to talk a little bit about, so Mother Nature's got a lot of authority in the snowpack, but, people, our municipalities, the way we develop around streams is where we really can influence rivers by releasing water or by the way that we use water on the land. And then we can go down here and landowners, be them government landowners like the Forest Service or BLM or, conservation easements or whatever, as well as private landowners can consider where they can improve habitat, either by protecting habitat or enhancing habitat, by creating pools, or just by keeping rivers connected in the way that we use streams. Are we building infrastructure in and through our streams that still allow for fish passage? So how can we reduce stress further? So temperature is controllable at a certain point or influenced. We can influence it at a certain point, but we also need to think about other things that impact fish and stress fish out. And that can be disturbances in our river corridors. What are we doing in them? When are we doing those things? A lot of what we do in my line of work is comment on what people are doing in our natural resources, right? How are they developing them? So from my perspective, we try to influence the regulators to have people do disturbance activities during less critical times of the year. So we do our best to reduce disturbance in the stream corridor when river temperatures are high, when stressful periods can occur. We also try to minimize disturbance in the river corridor during spawning periods. We can also address point source pollution and things that we do around our rivers so that we're not adding things into the river that might be reducing oxygen or causing stress to the fish outside of those thermal stresses. And we have developed water quality standards so we can make sure that we're meeting water quality standards, and those standards are based on the things that I've talked about with fish and when they stress. So we have our maximum weekly average temperature and our daily max. So we're talking a chronic stress versus an acute stress. And the way that these break out in the state of Colorado, the Water Quality Control Division has defined these standards and applied them to our cold water rivers. We have our cold water tier 1 fish here. These are our coldest tolerant fishes. And then our cold water tier 2 fishes. And basically in the summers in our streams, in the lower elevation tier 2 streams that have rainbow trout, brown trout, and mountain whitefish, average weekly temperature should not be over 65 degrees. And Mother Nature has a certain part to play in that, but also what we do around our streams has a part to play in it, and especially with our discharges, that's where this comes into play. Are people discharging things and making streams hotter? Are there ways that we can make our streams cooler by providing shading of our streams or diverting runoff from hot parking lots through wetlands or something to cool them off? Higher elevation streams have a maximum weekly average temperature of 63 degrees. So that kind of lines up with towards those red lines on my threshold graph that I showed you. And in the winter, we have standards. They have to stay cold, right? You can't discharge a bunch of hot water into our streams. That's not often as big of an issue as the summer, but it can be. And then our daily max. So our daily max for the tier 1 or the tier 2 fish, brown trout, rainbow trout, mountain whitefish is 71 degrees. We don't want to see that daily maximum reach that temperature, but we do around here. And then you start to get in some other regulatory triggers that are how often does it happen and for how long. And then in our higher elevation streams, our higher elevation streams can get a little bit warmer. We've shown that our native fish are tolerant of those warmer temperatures, but they do get warmer because there's less water up there and they are more susceptible to thermal influences from the air, but 70 degrees is kind of their critical daily max. So that's one way that we address my agency, the biologists, and researchers. We help inform these regulations by providing information that helps to develop those standards and keep them in place. And then the next thing, I went backwards. There we go. The next thing we can do as individuals is think about how we handle fish when we come into contact with them. Mostly that's anglers, of course. And what we ask people not to do is don't play your fish to exhaustion. Fish are stressed, particularly when conditions are bad, but they're stressed just by being on your line. And the more you play them, the more stress they get. And even if you feel like the fish is doing okay, and they might swim off, the longer you put stress on them and the more often they're caught, those are just going to be things that can impact a fish. So, minimize your disruption of their quality of life. Also keeping them in the water. And think about it, when you're pulling a fish out of water, it's like me holding your head underwater. I mean, how long do you want that to happen? We ask that people keep fish in the water when they're handling them as much as possible. And then, the Roaring Fork Conservancy has this great program that is a citizen science program that tracks hotspots for trout, but you can also go to river gauges or just bring a thermometer yourself when you're going out on low water, hot temperature days, and look at water temperatures in the river. If water temperatures are getting to be 68 degrees, your cold water fishes are starting to feel it. They're starting to not feel very good. So fish at period times of the day that are colder. And that is not going to be after the sun sets. That's typically actually when waters peak. You want to do it early in the day after they've had time to cool overnight. And then if worse comes to worse, you can always go upstream, just like the fishes are. They can go upstream too, but you should too. Go fish somewhere where environmental conditions are less severe. As for my agency,
Kendall.
oh,
Sorry.
yeah.
Sorry. Quick interruption.
No worries.
Thank you for the plug about hotspots for trout, and I'll talk a little bit more about that at the end, but I did share a link here for everyone to learn a little bit more about the program on our website. But I did want to add real quick that our volunteers actually did find 70-degree temperatures in the lower Roaring Fork last summer, which was, eye-opening for us. We were like, oh my gosh. The other thing I wanted to let you know is we have another question. It's from Jen. She works in agriculture. She's asking if you could repeat and expand on your point about irrigation practices and their regulation to groundwater and flow. Is there a best irrigation practice beyond simply trying to utilize water most efficiently? So Jen, if you want to expand on the question, feel free to unmute yourself. Okay.
So I would say, you want water on the land goes down, and it would be presumably for your plants, but then anything the plants don't use move right back down into groundwater. And then you'll see a lot of water coming out in streams that run along fields. In fact, right at our Crystal River hatchery, some of our water that we take out of the ground there to put into the hatchery is significantly impacted by the amount of irrigation that occurs on the fields just above. And that water goes into the wells that we use to collect water for our hatchery. It's just a great example of if that were, if those fields were to turn into, an urban development, we would probably lose a lot of that water that just goes to our hatchery. And that's just another system like the river that is also getting those cool water inputs. So you don't want, just those irrigation practices that don't spray a lot of water that evaporates into the air. Keeping it on the ground is really best. Does that answer your question? I hope so.
Jen, you can unmute yourself. I feel like I see her typing. You can unmute yourself if you want. It's fine. You're good? Okay.
Okay.
You can't. Oh, do you want me to try? Hold on, let me try it. Let me see if I can from this end. No. Oh, there it goes.
Sorry, I couldn't hit the button.
Okay.
We do flood irrigation, and so I just wanted to make sure that fit in because we like to guide ourselves on our practices. But if there was like a better way to irrigate, but you think flood would be maybe more preferable to those overhead sprayers because of that evaporation rate?
Yeah. And I think everybody would think, I think that's a better way to do it. Now, if you're flooding so much that you're running over the land, getting hot, and then dropping into the river, that's like a whole nother thing. Like, I'm sure there's a balance there with flood irrigation where you're using the water, just enough water to get your pasture wet, but not flow off the land. So there's always a balance.
Thank you so much.
Yeah. All right, so what else can we do? Okay, so now we're going into my realm of authority, or my agency's realm of authority, and those are managing anglers. CPW doesn't own a whole lot of land, so we don't do a lot of regulatory work on how people use the land. We inform other regulators. But what we really do is regulate hunters and anglers, and hunters and anglers are our tools in managing our wildlife populations, because obviously, especially on the fisheries side, a lot of our populations were brought here because of anglers, because people like fishing fish, and we've had a lot of fish introduced into our waters, and we continue to introduce some of those non-natives into those same waters when appropriate, for just the sport of angling. So what we can do to protect our local fisheries is manage our anglers through closures. You can have voluntary closures. We did this last summer where we advise anglers. We say, hey, conditions aren't just getting bad, they're bad. We need you guys to back off. We need you to fish early. We need you to fish somewhere else. And we will put up voluntary closures and ask anglers to comply. This is our preferable way, because I think everybody is invested in having healthy fisheries. We also have mandatory closures. So the opposite of voluntary is mandatory. And that's where we can make you do things. So how can we make you do things? Around here, we've got some seasonal fishing closures on 3-mile and 4-mile creeks and portions of the Roaring Fork River within vicinity of their confluences are closed seasonally to protect the spawning fish that go into those streams. In the spring, we've got rainbow trout that heavily utilize those. And then in the fall, if there's enough water, brown trout and mountain whitefish will use those. And one thing I didn't mention earlier, but while mountain whitefish are native to the western United States with all these spring spawning trout and so on, they are actually fall spawning fish. So they will utilize tributaries that are adjacent to the big rivers mostly to spawn, and they really only go up the first about 1,000 feet of a tributary to find a big pool and do their thing. They don't spawn like a trout and dig a red. They actually just kind of gather into a pool, and I say they throw their gametes at each other and then leave. So we try to protect those fishes when they are susceptible or more easily exploited by anglers in some of those important tributaries. And then we also have emergency closure regulation that we can use in response to environmental stressors, and that can be water temperatures when they reach 71. So if you'll notice, that kind of correlates to that water quality standard that we have. 71 degrees is the trigger temperature to say, okay, we're shutting down. And we do the mandatory close down if we ask anglers, we ask them to stop angling. We're telling you it's voluntary right now, but if we see that they can't comply and they can't just follow our suggestions, then we can go into a more forceful position and actually shut fishing down. That has not occurred around here. Just our seasonal closures, but I think those get good compliance. When there's unusually low flows, and our trigger there is if there's 51% or less of the average flow, then we will shut areas down, because typically then fish are having a hard time moving into different habitats, and they can become less sportingly available. They might all be trapped in a pool, and that's not really sporting. So we can do an emergency closure for that. And we, this year on the Crystal, had a voluntary closure that extended for quite a long time, even after temperatures rebounded, because there was still such low flows in the river. When we see fish condition deteriorating, so one sign of stress that I mentioned is seeing these infections that they can get from things that usually are not an issue, like saprolegnia or columnaris. Those are things that exist in the water column, but when they stop being able to have a healthy immune system, they're not able to fight off infections. And so you'll see fish, when people are angling for them, you'll see a fish that'll have a handprint that's got that is made out of like fungus, and it's really interesting, but that's a sign of stress. You'll see just large numbers of fish that have fungus on them in places where they might be rubbing on a stream, like on their nose or near their fins or on their tails, on not just the big old fish, but on fish of different sizes. You also might see fish that are listing. Maybe they can't swim up straight anymore. They're kind of listing to the side, or they might be gulping for air if, along with high temperatures, there's low dissolved oxygen. You'll see them at the water not going after a fly, but just sitting there gulping for air or for oxygen. They're not trying to get air in general. But so if we start to mortalities, we'll just, in these hot water years or warmer water years, we'll just start to see more mortalities in the river from whatever's going on. And then also low dissolved oxygen. So that trigger there is that 6 parts per million, or 6 milligrams per liter, is that stressful level for adult trout. So if we start to see that in some of our rivers, they'll see those kind of conditions set up in the Yampa River. Luckily, the Roaring Fork gets its name because it's high gradient, it roars. So luckily, we've got a lot of good oxygenation in our river, but in lower gradient sections of river, especially when they're not connected and there's not a high flow rate going through them, a turnover of water, you'll start to see low dissolved oxygen. And that also can relate to high algae growth too. When you don't have a lot of when you do have a lot of algal growth as well, you'll see low dissolved oxygen levels, particularly at night. So again, I've kind of talked a little bit about some of the local impacts that we've seen and some of the things that we've implemented, that the ways that we've been mitigating them. That went a little bit out of order, but CPW actions and regulations that we've put in place to address some of these local impacts include those voluntary closures. We've been seeing increasingly higher use during the summer, angler use, and just river use. So we've asked people not to fish during those stressful times of day. In the Eagle River, there are places that we've partnered with Trout Unlimited, and we just ask people to avoid some well-known kind of spawning areas where where somebody who might not know what they're looking for might walk right through them. We'll just ask people, we'll post a sign and just ask people to be careful. Those are kind of voluntary closures that we've implemented. Coming up in this new round of regulations that starts May 1st, we have started a limited mountain whitefish harvest. Until this year, you could take as many whitefish as you could collect. One of the things that instigated our spawning closures is we used to have people come and take a lot of whitefish when their spawning runs were going up the tributaries of the Colorado and the Roaring Fork rivers, and take literally coolers full home. And what we're seeing are some population impacts, and we're not entirely sure what all the impacts are, but I would say that temperature and some of these flow events, these rain events with high sediment are having some impacts, as well as just a lot of competition for resources out there, that we've seen a huge decline in whitefish in the Roaring Fork River. And so that in a number of our other rivers, we're seeing declines of whitefish even in their native habitat. And so we're asking that people harvest the same as trout. There's a 4 trout bag and possession limit. So hopefully, at the very least, we're going to address one of the potential impacts to the population, which may be harvest. We're not sure that it is, but at least that's one thing that we as an agency can address. We've also expanded our seasonal closures in the spring. We found that rainbow trout can be spawning a little bit later from time to time than we thought, and so we've extended our seasonal closures on our tributaries to the end of May. Is that right? Yeah, and or the end of, yes. Anyway, we've extended them 2 weeks longer because we were finding large spawning fish in our small tributaries, and we just want to make sure that those fish have an opportunity to successfully reproduce before they go back to the larger rivers. So those are some of the ways that we're addressing some of the impacts that we're seeing. Some of those are temperature related, or many of those are going to be influenced by temperature. And I think with that, I will take any questions, and yeah, thanks for listening.
Thank you, Kendall. I would say at this point, if you have a question, feel free to unmute yourself and ask the question.
Yeah, this is Tony. I'm just curious, Kendall, have you seen any changes in flow over the years? Is it more or less stable and the same, or is it going down, or any changes in the flow over the years?
You know, we are certainly starting to see more frequent lower flows, I think, with lower snowpacks. We also see water coming down our rivers at a different time than it has before. Earlier in the spring, we'll see more of it come down than having these like prolonged runoff periods. And so we've got less water in our summer periods. So yeah, it flow's certainly impacted. And then of course that can relate to how much water is being used, how much water is being taken out of the river for different uses, and how much water is being diverted over into other watersheds. So it's kind of hard to untangle those two, but certainly we're seeing water being available in a different way now than before, or than 20 years ago, maybe even farther back. But I think whitefish are kind of our canary in the coal mine a little bit. I feel like in the Roaring Fork, in the Colorado, we're just seeing a lot fewer of them, and I'm starting to, doing this presentation, just putting this together, I started going, man, I think temperature's got to be a much bigger influence on this that's driving this issue than anything. I'm betting that's what it is, but that's yet to be determined officially. So.
And for anyone that's interested, the Roaring Fork Conservancy sends out a weekly river and snowpack report year-round. So just one little paragraph summary. Rick and I go ahead and tell you what's going on with the rivers, whether it's mostly week by week pattern, but we also try to put in like something we're seeing over a broad range of time. And so the lower flows, like we'll talk about that as well. So Tony, I don't know if you're getting those or if other people are signed up for that, but I'll put a link here on the chat box where you can go see. Actually today, we release them every Thursday. So you can read it, but then you can also sign up for it in case you're interested. Cool.
And then you can also start planning your fishing.
Yeah.
Next summer's not looking so good right now.
One other thing.
Kendall, this is Quinn.
Hey, Quinn.
Are you seeing, like, this is just me fishing up on the Crystal. I feel like I've been seeing more mountain whitefish the last couple of years. Like last summer, I felt like I caught, you go up to, Marble area. I feel like I saw more mountain whitefish than trout sometimes.
Yeah, and there's a lot of whitefish that are up there, but if you hear, of course, I always feel like every old angling story, is the fish were bigger and more densely populated back then. And in some cases it's true, but the stories before, when I first got here, were you used to be able to walk across the backs of the whitefish as they were going to spawn up. I think it's Rock Creek, that is just upstream of the bridge as you're going into Marble. So there is a lot of whitefish in there, and I don't think people quite realize how many are in there. You'll also see them more when they start congregating in the fall. So if you get there at the right time, you might think there's a lot more than there really are, because they've just all come together.
Oh, makes sense.
But the Crystal's a cold river, and so it's a great place for them until it starts to get, a little bit higher. But I haven't caught them past Marble, but I know they're in there. They're doing well there. But man, in the Roaring Fork, I've pretty much documented a crash there of that population, which is really sad. And I think they're very sensitive fish to a variety of factors. I mean, temperature is one of them, but even when we're surveying, they are sensitive to handling stress. They are sensitive to anything. So if they've just got a bunch of little stresses kind of topped on, compounding, you can see how they're going to have some population effects there.
Totally, thanks.
Any other questions?
Can you hear me?
Yes.
Okay. My name's Katie. Hi. I was
Hi,
curious,
Katie.
if you guys had any foresight into, we were reading a lot of articles about Vail not seeding the clouds this year. And that affecting the watershed. And I was just wondering if you guys were concerned about that, or if you're planning on managing things a different way because of that. Because it seems like we have a really light snowpack already, and I don't know if that's because they're not seeding the clouds or if that's just normal.
We've had a very light snow year. I'm not sure if we know how much cloud seeding contributes snow and water. So I'm not going to manage anything differently, but that's something certainly to look at. I don't know how we'd quantify that. It would certainly be nice to understand how much that contributes, truly contributes. So.
Yeah, for sure. It's just something on my radar. And then I had another question, kind of off topic a little bit, but you deal a lot with the greenback trout, and we catch fish that sometimes look like greenbacks, but we're not quite sure how to identify them. And I was wondering if you had any markers that you look for that you're like, oh, that's greenback, that's not one, because that's what we sit around the table and argue about literally for hours. So just curious.
It's not going to be a greenback. I can tell you that much. We don't have very many true greenback populations in the state. They're all on the eastern side, but our indigenous population, the green lineage, which is very confusing, I know. But those guys, there are some around. Spotting patterns can be somewhat informative, but honestly, if you look at, usually the green lineage have less spots on the front half of their body than the Colorado River cutthroat trout, which are one of our recreational strains that are kind of everywhere across the landscape. There's a lot of overlap though, so you probably would have to ask me, and I'll tell you. I've probably sampled it or probably know what fish they are depending on the creek. So
Okay.
Yeah.
Well, thank you.
Yeah, no worries.
If you don't mind, I'll just jump in real quick to address Katie's cloud seeding question. Katie, we had a Watershed Institute about a year, I think it was 2 years ago, with Dave Kanzer from the Colorado River District, who did a whole presentation on cloud seeding and what they've been able to find, like how much does cloud seeding actually contribute to an increase in water content in snowpack. And there's more research coming out continuously. I'll post a link in the chat box where you can go watch his presentation, because he does present some really solid research. Of course, they're still studying it. And the other thing I just want to throw out there is that one of the misconceptions about cloud seeding, I'm not saying you have this, but the things we hear sometimes is they should be cloud seeding, but cloud seeding has been shown to work only if there's already a storm system coming. So we can't have clouds on beautiful bluebird sky days, which is unfortunately what we keep having. So we need a storm system to be coming in order for that to be effective. So we just need more snow. It's, if you read our snowpack report from today, it's not just the Roaring Fork Valley or even Colorado, it's the entire upper Colorado River Basin. So that's everything upstream of Lake Powell is below average. We're about 70% of our snowpack so it's 70% of normal where we would be this time of year. So gotta keep praying for snow. It's just not much we can do with it right now.
There's nothing to seed out there.
Right. Are there any other questions? I have some questions before we get off, but I want to make sure that people have a chance to ask them some questions while I find that link for everybody.
Does Jen have a question?
I found my
I'll call on you.
Yeah, eutrophication has been something that's been on my mind lately. And like two examples of why I'm thinking about it are like a few months ago fishing up by Rudeye, I think it's called the Toilet Bowl. There was like a fishing advisory and it seems super overgrown with like algae and plants. And then on the site that I live and manage, we have a lot of waterways drawing off the Roaring Fork. And I've been noticing what I think I'm observing is a lot more heavy plant growth coming into these waterways. And I was wondering if there are any like practical steps to take to kind of not fight that, but try to like counteract some of that.
Yeah, so more water always helps, like flushing it out. And we, on these managed waterways, you just don't have those big flushing flows that would keep some of those organisms in check that create those algal blooms or, Didymos, algae and a diatom that kind of work together to make these big blooms. So flushing flows help. The turnover of sediment helps, which is what, dams back up sediment. So you don't, usually rivers are turning over their sediment, it tumbles down the stream, that can help. So gradient helps. I know there are places where people fight algal growth in their streams. They're trying to have trout streams in these river valleys where there's no gradient. And I always keep saying, well, you kind of have to tip the earth. And that's really the best thing you can do, which you can't. But so some of those things will control it. Shading can help if you're a pond owner and you have these get these algal blooms, some sort of shading. So you either dig your pond deeper or you can put a coloring in your water that'll shade it so that it doesn't grow. But in our streams, I mean, most of the time it's these changed water regimes that have caused these algal growths to occur, that we're moving a lot of water out of our watersheds now. We're damming it up, we're damming sediment up behind reservoirs and not getting turnover like we need to control these populations of algae that are natural and can provide some good food, but they become a nuisance when they're out of control, when they don't have a natural control on them anymore. So not an easy answer.
And then just quick follow-up, I haven't quite ID'd what I see growing in the waterways at my site. Are there any like just couple key aquatic invasive plants to be concerned about?
I know water milfoil is a big problem. We're seeing a lot of that. It's like a coontail. People call it coontail. It can get mixed up with a native that has a spiral that goes the opposite direction. That can be a really invasive weed. In our rivers, I'm trying to think of plants that we're really concerned about. I mean, most of our rivers still behave in some natural manner that a lot of things can't get well established, but most of the nuisance we see are things that would be that already exist there. I know there's a number of aquatic nuisance weeds out there. If you go to like our ANS website on CPW's website, you can go through the links and see where there's problematic vegetation out there that you might look for.
Jen, you can also call or email us. I think our water quality program manager, Chad, it might still be on this call. I can't see all of the faces right now the way my screen is set up, but whenever we're concerned about that, he has received phone calls about that in the past. We've actually sent some samples out in the past to be identified to make sure either something native maybe that's blooming or maybe something that's not. So you can always call or email us as well to help with some of that.
That's an awesome resource. Thanks. I might have some milfoil.
Oh, yeah.
Give us
I
a
think
call.
we're dealing with it at one of our ponds too, so I'm gonna have to learn how to control it as well.
Are there any other questions? I have a question for you, Kendall, while other people are thinking about that. We do have about 8 to 10 minutes left. If you have a question, here's your chance. But here's my question for you, Kendall, because I'm sure I'm thinking it, and I'm sure there's other people thinking it when it happens. When there's a voluntary fishing closure that we know about because we're all plugged in, and then we drive down the road, we're driving wherever, and we see people fishing where there's a voluntary fishing closure. What do you advise we do, say, keep driving by? Like, do you have something, you know, is it appropriate for us to pull over and be like, hey, Rick LaFaro, you should know there's a fishing closure. I can pick on it, he's my boss. So, like, what do you advise? And then equally, when there's a mandatory fishing closure, especially for the seasonal spawning for reasons, what do you recommend we do at that time? Should we say something? Should we call one of your law enforcement officers? What do you suggest?
So with the voluntary ones, I mean, they're voluntary. You can be the guy if you want to be that guy to go out and fish. Sometimes people just don't know. People don't read signs. Maybe they're not connected. So I always assume that somebody is, you know, doing their best. So I think you just take it as an opportunity to educate. It helps if you've got a thermometer with you, if you really want to educate and say, here, let me show you. This is a warm stream right now. The fish aren't happy and you're going to have impacts on them. And everybody's asking for people not to fish. It's going to protect our long-term fishing opportunities by doing that. I think that's the best you can do with voluntary closures. If you want to pull over and educate, great. But by all, you know, at that time, if somebody really wants to fish, they can. And I think it's, you know, messages are better received when polite and friendly. Mandatory closures, that is something you can always call our office or our local officer if somebody is violating a closure or a regulation. Typically, you know, our guys have a lot going on. If I've done something, I don't do law enforcement, but if I see somebody doing something and I think something needs to be done, I've got a phone on me that has a camera, and I'll just take a picture of like their license plate or them standing next to the closure sign. That's my favorite picture, especially when they're leaning on it. And then they go, I don't know what you're talking about. And you can always kindly tell somebody, hey, you know, this area is closed. There's the sign. Otherwise, yeah, I mean, documentation helps if there's really an issue, but just informing people, one, what it is. I think if you're polite, that's fine. And And also it just lets people know that other people are around that care. And sometimes I think a little peer pressure can be helpful, but if it's really egregious, then an officer should be involved, contacting us, and then also any documentation can be helpful if there's some follow-up needed.
Great, thank you, thank you.
Yeah.
Any other questions? Okay, so I have one more question for you, Kendall.
Yeah.
I know that you do some fish surveys a few times a year, and I know that in the past you've called for volunteers to help you with that. So if people are interested in helping volunteer for your fish surveys, how do they get in touch with you or on your mailing list for that?
Yeah, shoot me an email and say you're interested around the Roaring Fork area on the Frying Pan. I'm usually looking for people, and that's every 2 years or so. I'll do surveys on the Frying Pan that I can always use a lot of help. And then in between, if there's opportunities, I'm happy to have somebody come out and help. That would be awesome. Just shoot me an email, and it's my first name, Kendall, last name, Backich, @state.co.us. And then that way I've got a record of you. I keep a little file of people who want to help, and then send out blasts when I can. Getting signed up on email lists from the Conservancy or your local organization, the Guide Alliance or Fly Fishing Club, those guys also, I'll reach out to places that have big groups too. So getting involved is helpful.
And I just mailed to the chat box so people have that.
Perfect. And then you can also shoot me other questions. I do my best to respond. If it's a really long question, my response might take a while. But you can call me as well. And the Glenwood Springs office number is pretty easy to find on our website, but it's 947-2920.
Great. So I'm going to go ahead and close this out since we have a couple of more minutes left. And I just want to thank everybody for joining us again. And I also want to invite you to 2 presentations that we have coming up in the next few weeks, or I should say in February. February 11th is our next Brookshire Watershed Institute, and the title is Yes, There Are Microplastics in the Atmosphere and the Aquatic Environment. So Dr. Janice Brahe from Utah State University, and then Austin Baldwin, who's a hydrologist with the USGS, are going to present on some research that they've done locally. By that I mean like in the region. So that'll be really, really fascinating, and that'll be a daytime presentation starting at 11:30. And then February 25th, Steve Hunter is going to come and talk to us about the Grizzly Creek wildfire, estimating post-fire watershed response. So you can sign up for both of those on our website, and I'll share the link here in a moment. You'll notice when you click on these websites that the way for you to register is a little bit different than you've done in the past, and that is because we are switching databases. And so you'll just register yourself in a Google document and get registered for that. And also, we feel like at this point we are going to have to bring back hotspots for trout this summer. And what I can tell you about hotspots for trout is that it's a citizen volunteer monitoring program where you're helping collect water temperature data wherever you are in the Roaring Fork Valley. So if you're going to go camping up at Chapman Reservoir and you're happen to be fishing up on some of those smaller creeks and rivers, we'd love to get some of that water temperature data. Last year was the 3rd year we brought that back, and normally we bring that back or reintroduce it during drought years, which is unfortunate. So, but at the same time, we're really fortunate because we ended up having like 25 to 30 volunteers last year who collected a lot of water temperature data for us. And we do share that information with Kendall and her colleagues because it helps us, it helps draw attention to some places that maybe we didn't know about were warming up. It helps draw our attention to send some scientists out there, collect some more information. And so one of the things that we did differently last year is that we provided calibrated thermometers to all of our volunteers because we wanted to make sure that the data we were getting was accurate. And the other thing we did last year is we actually created an app where you could upload your data, and it was like really fun and pretty and easy to read. And if it was too warm, it was bright red. And so when we would go look at the data, we would immediately be able to see where was it green, where it was fine, yellow, where it was a little bit starting to get warm, and red, where we were like, oh, we got to go tell Kendall about these places, or we have to send Chad out there to go get some more information. So I did share the link to hotspots for trout, but because you registered for this event, you will be on our mailing list. And so when we are calling for those volunteers, please email us and register for that, because we could always use more river stewards to help us fulfill our mission as well. And finally, this presentation is recorded, so give us a couple of days and we will get it live on our website, and so that you can share it or watch it again if you were curious what the specific things Kendall was sharing about about any of it. So, I don't know, Rick or Kendall, if there's anything else you want to add. Otherwise, thank you everybody for coming.
Yes. Thank you all.
Thank you.
All right, great. So hopefully we'll see you on February 11th for that presentation. Have a good night, everybody.